Next one here is the relative molecular mass. So earlier on, you have relative atomic mass. You can understand relative atomic mass as mass of one atom or relative mass of that one atom. So that means we can think about it as carbon atom is mass has mass 12 units. Then oxygen atom has a mass of 16 units. Then or I can understand fluorine as it has a mass of the chlorine atom has a mass of 20 units like that, relative atomic mass. Then down here, relative molecular mass can be understood as the relative mass for one molecule. So it's like mass of one molecule. Okay, something like that. So you are supposed to define relative molecular mass. You are supposed to calculate. The calculation starts. So then back to the definition of atoms and then molecules. So atoms is just one, right? Like that, right? Say sodium atom, that means they exist like that. Or hydrogen atom, it exists as standalone like that, right? And oxygen, you can also have it like that. So when we draw it, it's somewhat like this, right? If we want atoms, do they look like that? So then atoms, they can combine with other atoms or combine with themselves and form compounds, right? When you have bonding takes place and then atoms will form compounds. Then if in compounds, right, so usually they may exist as molecules. So that's how you get the water molecule that looks like that, right? Then I can have carbon dioxide that looks like that, right? But anyway, this is an animation where you have water molecules being formed from hydrogen and oxygen molecules. So hydrogen molecule will be like that, and then oxygen molecules will be bigger like that. So they're supposed to move and then they're supposed to collide with each other and then form water molecule, but then now it's not moving. So you need to know that molecules, okay, you need to know molecules and their formulas. Somewhat all this you have these examples. Now here you need to understand their combination. Then so let's focus on the water molecule. Let's say I have the water molecule which is like this. Then I say that I can imagine relative atomic mass to be the of one atom. So it's like the mass of one atom, right? So that means, right, if I want to find relative molecular mass, this is a molecule. So relative molecular mass, I can assume it to be the mass of one molecule. Right. So then that means the relative molecular mass will be the sum of the mass of these two hydrogen and the oxygen. So the relative molecular mass of water is the relative atomic mass of hydrogen plus relative atomic mass for oxygen, something like that. So if you go to the periodic table, you will find hydrogen is 1 here, and then oxygen is 16. So the relative molecular mass of water will be 1 plus 1 plus 16 equals to 18 relative molecular mass. Know what I'm saying? Yeah. So this is further explanation, further terminologies down here. So relative molecular mass is the relative mass for covalent compound. So that means they say relative molecular mass of water. We can say relative molecular mass of water, but you cannot exactly say, by right, you cannot say relative molecular mass of sodium oxide. So there's this term called relative formula mass, then that is for ionic compound. So if you see these words, these two terms in your books or in whatever assessment books or whatever guidebook, right, they mean this. But for us, right, for O levels, for N levels, we don't really care. We don't differentiate them. We just use relative molecular mass for both ionic and covalent compounds.
Means that one, the formula mass is for
It's for
O
ionic.
level.
No, that one is for A levels. So there's such a thing. So if you happen, sometimes, right, books they write a lot. If you buy guidebooks, a lot of books, then they write a lot, like they give you extra information. So then you may see the word relative formula mass. Yeah, you may see the word relative formula mass and then you know what is relative formula mass. So I am giving you the terms. So if you ever see them in books, right, then you see some relative formula mass pop out, right, then it means that it's the relative mass for ionic compound. If you see relative molecular mass, by right, it's supposed to be for covalent compounds. But N levels, O levels, we don't care about the difference. We just call them relative molecular mass for both. That's why I bold it in orange here to tell you that for us, right? For you, relative molecular mass means the mass for ionic compound and covalent compound. Okay? Yeah. The things are there to tell you for such thing. If you see them, don't panic. Okay? Yeah, it's just to tell you got such thing for warning only. So then you see the term relative molecular mass, and then it's very similar to relative atomic mass, right? Right. Yeah. So if you open your slides on relative atomic mass, you will see that it's like this. The relative atomic mass of substance is defined as the average mass of one atom of an element compared with 1/12 of the mass of carbon-12 atom. The blue one, right, I replaced, right? This is the one that is found in the definition of relative atomic mass. So
for the molecule just change to atomic, and the molecule change to atom, then the compound change to element.
Yeah.
Then it's the relative atomic mass.
Yes. So if they ask for this, is equivalent to ask for relative atomic mass, you just change the words. Yeah. This is the only definition they'll ask. Relative atomic mass or relative molecular mass. And the difference between the two is like this. So you remember one and then you just change the words from molecule to atom or atoms to molecules.
And
Okay?
the compound to element.
Yeah. Yes. Then another thing is, right, relative molecular mass has no units. So when I tell you units, please write your units, right? This is the relative molecular mass has no units. So you don't put units on it. Even though we say mass, but this has no unit. Because it's a relative molecular mass is actually a ratio. See, it's a ratio of these two things. So because it's a ratio, it has no units. Okay, next. So then if you want to calculate relative molecular mass of a compound or a molecule, it's just sum up all the atomic mass. So just now I say MR of water. The example I gave you just now, right, is just the atomic mass of hydrogen.
1 + 1 + 16.
2 times of hydrogen plus 1 time of AR of oxygen, like that. That's how you get 1 + 1, like that, then it's 18. Why is 1 + 1? Because you know there are 2 hydrogen atoms. Okay? Yeah. Say example is here. Magnesium oxide has a chemical formula of MgO. Then they say calculate the relative molecular mass. So you have MgO. So relative molecular mass of MgO will be magnesium plus oxygen. So how? So the 24 is this one, the 16 is here. Yeah. Then now this one I leave it to you. Then we divide this page into 3 sections. So this one you write your answer for sulfuric acid in this window. Then this here. Then this here. If you find it difficult for the last one, it's fine. I would talk about it in a while.
SO4. That's sulfur and oxygen.
So there's sulfur, oxygen, and hydrogen. So here, if you find it difficult, you can draw it out. There is 2 hydrogen, right? Then there's 1 sulfur. Then they tell you there's 4 O2. I anyhow draw that. The molecule may not look like that. So I change this to a drawing. Then you can start counting. Okay, try to draw the other 2. Then I can tell you whether your drawing is correct. How if you understood it correctly. Then after that, then you can do the question 64. Where did the 64 come from?
16 times 4.
Correct. Later I'll draw mine and then you see whether it's correct or not. It's the same as yours. So the second one, right, it means you have 2 groups of NH4. You have 2 groups of NH4, so you should have 2 nitrogen. Then you have 1, 2, 3, 4, 8. 1, 2, 3, 4, 5, 6, 7, 8 here. And then 1 carbon,
Hydrogen.
3 oxygen.
3 oxygen.
So you have 2 nitrogen, 8 hydrogen, 1 carbon, 3 oxygen. So for this one. So then
For
then
the
you
last one, I just gave drawing.
Then the last one here, you have 2 sodium. In your drawing, you should have 2 sodium. Then have 1 carbon, 3 oxygen.
For the last one, I just gave up drawing it.
You don't have to be particular about it because it's just a sketch. It doesn't mean that the real molecule look like that. I also anyhow draw.
The letters cannot eat,
Yeah.
and it's hard to draw with a mouse.
Yes, I know. That's why I say I draw once and then you look at it. If you think it's the same as yours, then we are good to go. I'm not particular about how well and how nice it looks like. I just need you to show that you know how you count this thing. So sodium, also anyhow draw H2O. Yeah, H2O. So there are 4 H2Os. So that means you have 4 groups H2Os together with the sodium carbonate. So you're gonna have something like that for this case, all in one. So with that happening, right, that means you will have 2 sodiums plus 1. You see, draw only 1 carbon here, so 1 carbon. Then how many oxygens are there? I have 4
oxygen.
Okay, say down here.
7 oxygen.
Yeah, because there's 1 here, 2 here, 3 here, 4 here, 5, 6, 7. So 7 oxygen and how many hydrogen?
8
So
hydrogen.
1, 2, 3, 4, 5, 6, 7, 8, 8 hydrogen. Then now you can add up the mass. I draw this, I tell you to draw it because then you can see clearly how many are there and then you can count properly. But if you can look at the formula and you can count straight away, then good for you, you can skip this step. 14 plus 14, 2 nitrogen, 1, 2, 3, 4, 5, 6, 7, 8 hydrogen, then 1 carbon, 2, 3, 4. What you can write is this. Relative molecular mass is 2 times 14 plus 8 times 1 plus 1 times 12 plus 3 times 16. Then you get the answer also. So it will be 2 times 23, then 1 carbon, 7 oxygen, and 8 hydrogen. There's 7 oxygens. 2 times 23 plus 12 plus 16 times 7 plus 8. You want to recount. You see down here, I gave you the statement here. I counted for you just now. So you can do 2 sodium plus 1 carbon plus 7 oxygen 16 plus 8 hydrogen. Okay, so next. Okay, so now it's recalling. You need to know how to do chemical formulas, then you can get the correct molecular mass. So rubidium, okay, this one, balancing equation D. Okay, let's see. So there are 2 ways to do this. One is to balance it yourself, then check the coefficients, or you just try and error, put in the numbers and check. So you put this. So let's balance. Then 3 times 2, 3 times 2, okay. Then 3 copper, 3 copper. Then 3 oxygen, 3 oxygen. Yep, answer correct. D. Next, more recalling. I think this will be the last slide. Calcium nitrate, zinc hydroxide, magnesium carbonate, ammonium sulfur. Got problem. Want to reconsider? Ammonium is like this. Sulfate is like this. So it's 1 here, 2 here. Then you switch the numbers. Yep. Okay. So you are supposed to name the chemical compounds and then calculate the relative molecular mass. Sodium sulfate, 23 plus 23 plus 32 plus 16 times 4. Sodium sulfate is correct. Then, okay, this is 119.
111.
Okay, so sodium, there is Na2, that means it's 2 sodium atoms. Then 1, you see sulfur around there is 1 sulfur. Then oxygen, you see a 4 there, that means it's 4 oxygen. So when you want to find your relative molecular mass, yeah, so it should be 2 times 23 plus 1 times 32 plus 4 times 16. Then you get 1.
Then unit for molecular mass.
Is
there unit?
Sorry?
Is there any units?
Low net, sorry, cannot hear.
Is there any units?
No unit. Molar mass has units, but relative molecular mass has no units.
There's molar mass in my syllabus.
Yes, there is. So then the other one is
The atomic mass and the molecular mass is the same formula.
Relative atomic mass is the one that you get from the periodic table. Relative molecular mass is for compounds. Then you add up all the relative atomic mass of the elements inside the compound. Then you get relative molecular
Means the
mass.
atomic mass is the mass of one atom.
Yes. the relative mass of one atom.
And it's the one in the
Yes.
periodic table.
Yes.
But then isn't the molecular mass also from the periodic table?
No, relative molecular
Add up
mass
with the
is
compounds,
yes.
then add
So
up with the rest.
so that means you are actually relative molecular mass equals to adding up all the relative atomic mass, adding up all the atomic mass. So then this one will be 27, 1 aluminium and 3 oxygen and 3 hydrogen. So that means it's 1 times 27 plus 3 times 16 plus 3 times 1. Then your answer is correct here. Then last one, ammonium nitrate. Then your working will be 2 nitrogen plus 4 hydrogen plus 3 oxygen. So it's 2 times 14 plus 4 times 1 plus 3 times 16. Same? Yeah, 80, correct. Okay, we'll go to the next one. Name these compounds again and then calculate their relative molecular mass. Yep, magnesium carbonate plus hydrochloric acid gives you water, magnesium chloride, and carbon dioxide. Mg, Mg, H2, H2, CCO3. Okay, balance. Iron plus sulfuric acid gives you iron sulfate plus ammonium hydroxide plus sulfuric acid. So at first you have this. So this is balanced with this. This is balanced with this. Then this one is like that. Ammonium sulfate is NH4 plus SO4 2 minus. Switch. It's like that. Yeah. So you have then 2 here so that you can account for 4 hydrogen, then 2 oxygen. Like that. Okay.